Hello friends, welcome to TIC Exams. In this video, we will learn about the concepts of probability and some of the examples also. I am Syed Sadath. I am a mental ability trainer for UPSC, KPSC, Staff Selection Commission and various other competitive examinations. Okay, so let's get started. What is this probability exactly? Let us try to understand from some real life examples. For example, you might have heard about weather forecasting, right? That is like Tuesday it could be sunny, Wednesday it's going to be cloudy, Thursday it might rain, and so on, right? So for example, let us assume you're planning for a picnic with a family and you want to visit a place. So before visiting that place, you definitely try to check out what would be the weather there. Okay, if weather is favorable, then you will definitely plan the trip. If weather is not favorable, you might cancel the trip, right? So for example, going through a weekly schedule of forecasting, as you can see on the screen, Thursday it looks like there's going to be rain, right? There's going to be rain on Thursday and the chances of rain are 60%, which means there's high probability of getting rain on that day, that is Thursday. So you might not want to visit on Thursday, right? You want to check on Monday. Chances of rain are 20%. So very low chances of rain on 20% on Monday, for example. So you might like to travel on Monday because there's no rain or very less chance of rain, right? Similarly, Sunday also if you see, there's no idea. So like this, we will use probability in real life examples, and one of them is weather forecasting. Let us look at another popular example. You might have heard about lottery ticket. So many people are crazy about lotteries. They want to try their luck. So they'll pay some small amount, say 10 rupees, 20 rupees and so on, and buy a lottery and wait for their luck. Okay. So same amount of money, there will be lakhs and thousands of many people will be paying for that lottery, and out of them one or two or some of them could be lucky winners. All right. So in lottery ticket also the concept of probability is used. Okay. Then one more famous time pass game, that is playing cards. So many people have the habit of playing cards. So here also there is a probability of getting a jack, getting a queen, getting a king and so on. So here also we use the concept of probability. Then insurance. Many of them, when all of us in fact, fear for our life, fear for our properties or for our assets, right? So we want to cover the risk. We know there is a risk, so we want to cover the risk. So to cover the risk, we buy insurance. It could be for our life insurance, it could be health insurance, it could be property insurance, or it can be mobile insurance. Okay, nowadays mobile insurance is very common because the chances of the mobile getting damaged or getting stolen are very high. So to prevent that risk, we buy insurance. So in insurance also the concept of probability works. Tossing a coin, I'm sure you might have heard and all of you have seen, before beginning any match, in fact cricket matches, if you see, there's going to be toss and tossing a coin happens. So here also probability is coming to use. One more famous is throwing a dice. When you throw a dice, you might get, if you throw a die, we'll get 1, 2, 3, 4, 5, 6, any numbers. If you throw dice that is more than one, you will get more than one numbers also. So here also we use the concept of probability. Now let us try to understand what does it mean. What does probability mean? Probability simply means possibility. That's it. Okay, possibility. What is the possibility of some event happening? What is the chance that something will happen? Okay, so in the problems it is actually denoted by a number. Okay, it will be denoted by number which reflects the chance or likelihood that a particular event will occur. That for example, tomorrow it might rain or it may not rain. India may win, India may lose. Okay. So these are all the possibilities. Okay. Probabilities can be expressed as proportions. They are expressed as proportions ranging from 0 to 1. That is, it can be represented like 1 by 2, 2 by 3, 1 by 5 and so on. So it ranges from 0 to 1. Nothing less than 0, not more than 1. Okay. They can also be expressed as percentages ranging from 0% to 100%. Okay, which can be 20%, 30% and so on. Like that also probability can be expressed. That say instance, for example, tomorrow the chances of raining are 40%. Day after tomorrow chances of raining are 80%. Like that also we can use probability. A probability of 0 indicates that there is no chance that a particular event will occur. It is called as impossible event. So whenever you solve probability, if you are getting the answer as 0, it means there is no chance that that particular event will occur. So it is called as impossible event. If the probability is 1, it means the event is certain to occur. It is guaranteed, it is sure that that event will occur. It is called as sure event, okay, or certain event. Let us try to understand when it is given as decimal points. Suppose if the answer of probability is 0.45, 0.45 means 45%. That is 45 chances out of 100, because 45 divided by 100 is what is called as 0.45, and we know 45 upon 100 means 45%. So that means there are 45 chances of that particular event happening out of the 100 possible outcomes. Okay. Let us try to understand some of the basic terms of probability. The first one being experiment or trial. A series of actions where the outcomes are always uncertain. They are called as experiments or trials. A trial can be tossing a coin, throwing a dice, shuffling a card. It can be anything. This is called as trial, where the outcome is not sure. We don't know exactly what can be the outcome. Okay, it can be anything. Now, what is the outcome? Outcome means a possible result of a trial or experiment. Whenever a trial is conducted, an experiment is performed, then the possible result that can come is called as outcome. So, in this case, throwing a dice is a trial. Getting that number 2, 3, 4, 5, 6 or 1, anything, that is called as outcome. In shuffling of cards, the shuffling of cards is called as trial. But getting a jack, king, queen or any number is called as outcome. Similarly, while tossing a coin is called as experiment or trial, but getting head or tail is called as outcome. Alright. So for example here in dice, when you throw a dice, getting 1 is an outcome. In card, getting a jack can be an outcome. In the coins, when the tossing the coins, getting head or tail can be outcome. Alright. Event. What is this event? Event means it is a single outcome of an experiment. An event means a single outcome. For example, when we toss the coin, if we get head, it is called as an event. Okay. Getting head is an event. Getting tail, yes, that is also an event. So one event means one time it will happen. Okay. Now what is sample space? This is very important. Sample space means set of all possible outcomes in any trial. All possible outcomes, whatever the possibilities are there in total, they are called as sample space. For example, when we toss a coin, what are the possibilities? It can be head, it can be tail, right? So this head and tail are called as possible outcomes, and that is called as sample space. It is denoted by S and they are written as H comma T, head, tail. Now what is this N of S? This means number of possible outcomes. N, numbers, total. How many numbers here? H and T together, total 2 numbers. So N of S here will be 2. So number of sample space, that is number of possible outcomes, is 2 here. Similarly, when we throw a dice, what happens? When we throw a single die, if we throw a single die, total possible outcomes are 1, 2, 3, 4, 5, 6. So all these numbers are possible, right? When we throw a die. So what is N of S? That is number of possible outcomes. 6. It is 6. We might get 1, we might get 2, we may get 3, 4, 5 or 6. So there are total 6 outcomes when we throw a dice. Alright. Let's try to understand some more terminologies. Complementary event. What is this complementary event? The event, if it is not happening, that is non-happening events, are called as complementary event. For example, if head is happening, when we toss a coin, if head is the answer, then tail will not happen, right? If head is coming, tail will not appear, right? So if I say this event is A, this is called as not A or A dash or even A bar we can represent. Okay. So here complementary event means if one event is happening, another event is not happening. Whatever is not happening, that is called as complementary event. So in this case, in tossing a coin, if head is appearing and we are taking this as event A, then complementary event is tail, which is not A. Not A means basically not head. Okay. And one more thing, important thing about this complementary event is together they will add up to 1. That is probability of event that is happening and probability of event that is not happening in one experiment. They together join together and the total is equal to 1. Alright. So here probability of getting a head plus probability of not getting head is equal to 1. Fine. What is the formula to find the probability of an event? It is very simple formula. We have to know what is the number of favorable outcomes divided by total number of outcomes. That's it. So how do we write it? Probability of E is equal to number of favorable outcomes divided by total number of outcomes. Okay. Number of favorable outcomes can be denoted by N of E, or you can use any term, that's absolutely fine. N of E, E for event, N of S, S for sample space. So probability of event is equal to number of events divided by number of sample space. So this is the formula we are going to use when we find the probability of an event. Alright. What are the other formula we might use? Okay. Suppose in the question they are asking probability of A or B. If it is A or B, then we will use it as A union B. And here A means one event, B means another event. So we have two events here. One is A, another B event in the same sample space. So probability of A or B occurring is given by P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay. So what is P of A here? P of A means probability of event A happening. Okay, P of B means probability of B, and what we do, we will subtract P of A intersection B. A intersection B means probability of both events happening together. Okay, so this formula we will use, and in case if the events are mutually exclusive, we will simply use probability of A plus probability of B. Mutually exclusive means if one event is happening, another event will not happen. That is, together they cannot happen. Now, if the question is about probability of A and B, we will simply use P of A into P of B. Okay. If the complementary events, we have already learned that P of A plus P of A bar is equal to 1. So, we have already learned this point. Let us go through one example now. Okay. So, let us go through first example. Find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. Okay. So, how do we solve? We know the formula, probability of E is equal to N of E by N of S. That is number of favorable events divided by total outcomes, right? Okay. So, let us see what is the sample space. Okay, remember friends, whenever we solve probability, first thing we have to note down is what is the sample space. This is very, very important. So, sample space here is when we toss a coin, we may get a head, we may get a tail. So, head, tail. So, what is N of S? That is number, total numbers. How many? We will get 2. So, N of S is equal to 2. So, total number of events or outcomes here is 2. So, what we will do here? In the denominator, we will write 2. Now, in the numerator, favorable event, that is favorable outcome of getting a head. How many? Only 1. In this, how many we have? Head we have only 1. So, it is going to be 1 by 2. Okay. So, probability of getting a head when a coin is tossed once is 1 by 2. Same way, probability of getting a tail, same thing again, sample space we will write 2. Now, how many tails we get here? If you see, we get only 1 tail. So, it is going to be 1 by 2. Now, next we will go for example 2. A bag contains a red ball, blue ball and a yellow ball. Smita takes out a ball from a bag without looking into it. What is the probability that she takes out yellow ball, red ball or blue ball? Now here, first we will see the sample space. Alright, what is the sample space? That is the denominator. Total outcomes. Total outcomes we know, we have 1 red ball, 1 blue ball and 1 yellow ball. So total how many? Total we have 3. So in the denominator we will write total 3 balls, 3. Now in the first case we will try to see, we have to get yellow ball. So how many yellow balls we have? We have only 1 yellow ball. So we will write it as 1 by 3. This is the answer. Same way when we try for the second one, total number of outcomes remain same. Total 3 balls are there. Now the question is about red ball. How many red balls we have? We have only 1 red ball. So again 1 by 3. Same thing happens for yellow ball. Total outcomes 3 because we have 3 ball. Sorry, this is for blue ball. Yeah. Third one is blue ball. How many blue balls are there? Only 1. So it's going to be 1 by 3. So the answer remains same, 1 by 3, 1 by 3, 1 by 3. That's it. Okay. So what we do when we get this type of problem, first we will add all the balls together. Then take that into denominator. Okay. And for each event, we will go according to each how many balls are there. Example 3. Find the probability of 5 with a die. Okay. So what we will do? First we will find out what is the total sample space. We know very well there are 6 outcomes. So we will write in denominator as 6. Now probability of getting a 5. 1, 2, 3, 4, 5. How many we get 5? How many times? Only one time we will get 5. So the answer is 1 by 6. Okay. Next example. A card is drawn from a pack of well shuffled cards. Find the probability that it is a queen, it is a spade. Okay. So what we do here, first thing is total sample space. Total how many cards are there? 52. So n of s is 52. So in the denominator, what do we write? We will write it as 52. Okay. Now the first question is about getting a queen. How many queens are there? Are you sure how many queens? Let me just show you one example. Let me just show you how exactly this deck of 52 cards look. This is how it looks. This is the deck of 52 cards. If you see, we can have look at 4 rows. These 4 rows are called as clubs, spades, hearts, diamonds. So 52 cards are divided into 4 equal rows. So each row contains 13. That is 13 clubs, 13 spades, 13 hearts, 13 diamonds. Okay. So these 4 rows, then each of them have same cards. That is, for example, A, ace, then we have 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Then we have J, jack, Q, queen, K, queen, king. So all of them have the same type of cards. Okay. And then clubs and spades are black in color. Hearts and diamonds are red in color. Okay. Now let us see what is the total number of queens. Total queen. How many queens are there? If you observe, we have 1, 2, 3, 4. So total 4 queens are there. So in the numerator, total 4 queens it goes. Fine. Now, so first answer is 4 by 52. This will get divided further. 4 1 times and here 4 13 times. So 1 by 13 is the answer for getting a queen out of 52 cards. Now the next one, how about spade? So we know very well sample space remains same, 52. Now getting a spade, how many spades are there? If you look at the design, we have total 13 spades. So it will be 13 by 52, which is nothing but 1 by 4. Okay. So the probability of getting a spade is 1 by 4 and probability of getting a queen is 1 by 13. Alright. Next, let us look at one more example. A card is drawn random from a normal pack of cards. Find the probability that it is either diamond or a king. Okay. So what is happening here? Total number of events. Outcomes how many? We have got 52, right? So total number of outcomes, we have got 52. Now first one they are asking either diamond or a king. When the question is like that, that time we will use this formula. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So let us do one by one now. First we will find out what is the probability of A. Here A means we are considering diamond. What is the probability of getting a diamond? So we know very well sample space is 52 and how many diamond cards we have? We have 13 diamonds here, right? We have got 13 diamonds. So it will be 13 by 52. Now probability of B is getting a king. So sample space remains same, 52. How many kings we have? We have 1, 2, 3, 4. So we have got 4 kings. So 4 by 52. Okay. Next we have got getting a king and a diamond. A intersection means B means both getting king as well as diamond. If you observe carefully here, we have all these 13 diamond cards. In this we have got one king also. This means king is already present in diamond. So it is getting duplicated. The number is getting duplicated. We have already counted the 13 diamonds. And when we count the king, it is getting duplicated. So we have got one duplicate here, which is actually repeated here in diamond. So one king is getting repeated out of 52. 1 is getting repeated. So what we will do now is we will simply substitute the value. Probability of A 13 by 52 plus probability of B 4 by 52 minus probability of A intersection B, that is together the common one, 1 by 52. So 52 is the base for us. 13 plus 14, 13 plus 4, 17 minus 1, 16. So 16 by 52 is the answer. So this goes 4 times. 4 4s are 16. 4 13s are 52. So the answer is 4 by 13. The probability that it is either a diamond or a king is 4 by 13. I hope this video was helpful to you. Please subscribe to our channel and like and share this video. We will come in our next video with some more examples and also some solved questions of previous examination. Okay, keep watching. Thank you.